So today, we're diving into something called the Temporal Phase Coherence System. I know, it's a mouthful, but stick with me, because it's this really fascinating and super ambitious way of looking at human performance. All right, let's just jump right in with a question. You know those days when you're just on fire? Like, everything you touch just works, you're totally in the zone, effortlessly productive, and then, the very next day, it feels like you're wading through mud. Every single task is a monumental struggle. We've all been there, right? Well, we're about to explore a pretty wild new theory that might finally explain why. So you can really think of this as two completely different ways of operating. You've got your flow state, right? That's when you're in the groove, high output, and it feels like it takes almost zero effort. And then you've got the total opposite, the high friction state. This is where you're struggling, you feel totally out of sync, and your productivity just tanks, no matter how hard you try. So what if the key to all this, to shifting from that friction state to a flow state, has nothing to do with psychology or motivation? What if the answer is actually hiding in the intersection of pure geometry and, get this, brutally rigorous computer code? Yeah, that's the wild idea at the heart of this whole system. Okay, so to really get how this works, we got to start with the basics. We need to look at the three fundamental rhythms that this model says pretty much govern our lives. We're talking about the daily, the monthly, and the yearly cycles. So this entire model is built on these three fundamental clocks, or what the system calls oscillators. First, you've got the circadian rhythm. That's your basic 24-hour clock. Then there's the Circa Lunar, which is the 29.5-day lunar cycle. And finally, the Circa Annual, your 365-day journey through the seasons. Now here's the core idea. The theory says our performance is a direct result of how well these three clocks are synced up. Okay, but here's where it starts to get really, really interesting. The system doesn't just, track these clocks with a bunch of numbers. No, it actually maps their relationship using this totally unique geometric metaphor. At the very heart of this is something called a dual triangle paradigm. So picture this. Our own personal analytical point of view, what's called the observer frame, is modeled as a right triangle. And you might be asking, why a right triangle? Well, think about it. A right angle is the basis of how we measure everything, like a ruler or a grid. It's how we logically try to make sense of the world. But then you have the ambient structure, the natural cycles of the environment. And that's modeled as an isosceles triangle because it represents symmetry. Just think about the seasons, waxing and waning, or how the moon's phases are a mirror image of each other. So you've got us, a right-angled ruler, trying to measure a symmetrical world. And that fundamental mismatch, that's where the friction comes from. Now, it's really important to pause here because the source material is super clear about this next point. This is not some metaphysical claim that reality is literally made of triangles. Not at all. It's a formal mathematical model. Think of it like a map. It's a tool that lets us measure and predict the relationship between our inner state and the outside world. It's a map, not the territory itself. Okay, so if we can model all these cycles with geometry, does that mean we can actually calculate the cost of being out of sync? The answer is a big yes. And the system has a name for that cost: friction. The friction tensor, that's the real engine of this whole thing. It's basically a formula that calculates the geometric distance between the phases of our three clocks, the daily, monthly, and yearly ones. And it spits out a single number. That number tells you exactly how much energy you're wasting by being out of sync. The handbrake analogy is perfect. Imagine driving with the handbrake partially on. Yeah, you're still moving forward, but you are just burning through fuel, fighting against yourself. And what's cool is that this model can be personalized for you. It uses these things called coupling constants. Just think of them as your own personal sensitivity dials. You can tweak them to show how much you personally are affected by the lunar cycle, or by the changing seasons, or even just the baseline friction of your specific environment. So after all that math, the final output is actually beautiful in its simplicity. It's called the coherence index. It's just a score from 0 to 1. If your score is low, it means you're in a high friction state, basically swimming against the current. But if your score is high, that means you're in a state of high coherence. You're in flow, and all your energy is being put to good use. And here's the real kicker. The beauty of a model like this is that if you can measure something, you can start to manage it. So this isn't just a fancy way to describe why you had a bad day. It's prescriptive. It actually offers real, concrete strategies to help you navigate your own temporal landscape. One of the key strategies it proposes is something called the Sabbath protocol, and it's a way to deal with those high friction periods. It's actually pretty simple. It just means taking a day for intentional rest, decoupling yourself from your strict daily schedule.
The idea is to give your internal clocks a chance to just relax and naturally get back in sync with those bigger, slower-moving lunar and seasonal cycles.
But this thing's ability to calculate friction, it doesn't just stop with you and me. When you scale this model up, it can do a lot more than just help you plan your week. It can actually forecast moments of, well, universal significance. And it makes one prediction that is truly jaw-dropping. It predicts something called a super mesh event, a moment when everything aligns almost perfectly. And it gives a date. The system predicts that this incredibly rare triple alignment will happen on March 19th and 20th, 2026. On that day, you'll have the spring equinox, a new moon, and solar noon all lining up. In the language of the model, the yearly, lunar, and daily cycles will all hit their 0 point at the same time.
And this isn't just a cool piece of trivia. It leads to some very direct, very actionable advice. Just think about that for a second. We have a mathematical model of time that is giving us a specific 2-day window years in advance, and it's recommending that you schedule your most important, highest leverage activities, major life decisions, creative breakthroughs to happen right then. It's pretty bold.
So, okay, up to this point, we've been looking at this fascinating, almost philosophical model of time and human performance. But now, the story is about to take a really sharp turn. We're moving away from abstract theory and into something completely different. So you have to ask, is this just another elegant idea that's going to live and die in some academic paper? Or could it actually be something more tangible, something verifiable, something absolute? Well, the people behind this system are putting their theory to the ultimate test. They are grounding every single piece of it, the geometry, the friction calculations, those big predictions, in a set of brutally rigorous software specifications. They're not just writing a paper about it. They are building a protocol. And when I say rigorous, I mean it. The rules for this protocol are unbelievably strict. You have things like binary is law, which means the raw binary data is the one and only source of truth. No wiggle room. No floats or JSON numbers. That's to get rid of any and all ambiguity. They're using fixed point math only, which guarantees that the calculations will be perfectly reproducible on any computer anywhere on Earth. This isn't just about writing code, it's about creating a mathematical contract. And this quote really nails the heart of what they're doing. The whole goal is to create a system that is so precise, so unambiguous, that its state can be proven. If two different computers run the protocol and get different answers, you can trace it back to the exact point where they diverged. The theory stops being a matter of interpretation. It becomes provable. So this whole journey from abstract geometry all the way to absolute verifiable code, it really leaves you with a big provocative question, doesn't it? What other huge ideas, what other cosmic theories about our world are just sitting out there waiting for someone to make them real with the unbreakable certainty of code?